Eric Darling here with Eric Darling Data, recording the third YouTube video of the day. Isn't this lucky? Isn't this lucky for you lucky people? I've had a lot of other things to do, including listening to some construction. But I wanted to get some stuff, some blogging and some video recording out of the way because, damn it, I'm sick of seeing it pile up in my to-do list. So here we go. Now, no one ever believes consultants for a variety of reasons, which I totally understand. No one ever believes us consultants, but I need you to believe me because I work with people who are not as well versed in SQL Server as you. And so they make mistakes in their queries that I think you, dear reader or dear watcher or listener or whatever, might not exactly make, but maybe you'll at least get some entertainment value out of this anyway. Like, no one believes wrestling is real, but a lot of people are entertained by it. All right, cool, fine. I'm not a snob about that. If you want to watch wrestling, do your thing, man. I'm not worried. So we have a couple queries here, and these queries do something that I consider ridiculous, and that you, as right-thinking Eric Darling Data watching people, would also probably think is ridiculous. It's a join on a case expression. So what do we have here? Two queries, one filtering on reputation equals 11, another filtering on reputation equals 5. And when we look at the query plans for these, now, because I've created pretty good indexes here, both of these queries finish relatively quickly. This one's about 1.7 seconds, this one's about 1.6 seconds. But I need to walk you through a few things. These are parallel plans with a hash join in them. Because this is a parallel plan with a hash join in it, SQL Server has chosen to implement a bitmap in order to help us reduce row counts on the inner side of the hash join. We have the bitmap filter here where it gets created, and this is correct. This is where it gets created. This is where SQL Server creates a bitmap based on values that it's seen from here. This is going to be a bitmap on the ID column coming from the users table. And normally this bitmap would end up all the way over here at the index scan, but it doesn't. Why? Because there's an operator here that we can't push the bitmap past. We'll show you another example of this in a minute. So SQL Server can't push the bitmap here. It gets stuck at repartition streams. One, very good indicator, and a very obvious indicator that this is what happened, is that if we look closely at the row counts in the query plan, SQL Server, or rather, the query plan shows us that every single row has come out of the clustered index here. But not every row has made it out of the repartition streams operator. In fact, the repartition streams operator has narrowed the number of rows down quite significantly. That's 3 less digits that come out of, 3 fewer digits that come out of here. So the bitmap gets created here, which is true. The bitmap gets created based on the index seek. But because we have this operator between the index scan and the repartition streams, SQL Server can't push the bitmap past here. So normally the bitmap could come over here and do this filtering, but in this case we can't. It's the same deal in this plan, right? We can see a lot of rows go into repartition streams, very few come out, but every row comes out of here, and we still have the compute scalar here. With that out of the way, here's kind of a funny thing. There are two very different numbers of rows that come out of this and that come out of this. So these seeks into the users table have very different numbers of rows that come out, like 117,000 versus 7,284. That's a big difference, and at the end of the query day, there is not a whole lot of difference between the times here. I know it's like, what's that, around 100 milliseconds? That's kind of crazy for the row disparity there. Now, one potential way to rewrite this query would be to do something like this, where you would select from one table based on one condition, union, because remember we have distinct up here, and then select from the other table based on the other join condition. If we do that, well, oops, we're going to hit the wrong button first because we're idiots. Why not, right? Let's be dumb together. This query is going to run for about 2 seconds, which is a little bit worse. And normally you say, Eric, you're a professional query tuner. What the hell just happened to you? You got hosed by this thing. Well, sure, a little bit, but I rewrote the query that way because I want to show you something that's also interesting. So up here, we have a far more efficient join pattern for a small number of rows, right? That comes out of there. We are able to do this down here, and we're able to seek into the post table down here because on the post table, we have the index on last editor ID and then owner user ID, right? So up here, where we're joining to last editor owner user ID, we are able to seek efficiently into that index. Down here, where we're hitting owner user ID, we'll see a couple things about this index scan. One is that, again, there is no bitmap probe here. The other thing is that we have a hash join here with the bitmap here because since the owner user ID is the second column here, it would be less efficient to do nested loops join and scan the post table a whole bunch of times. It's much more efficient for SQL Server to do a hash join based on one big scan here and here. The other thing is we have a similar problem. We have this hash match partial aggregate. This hash match partial aggregate means that when we go to push the bitmap from here down to here, we can't do that. It's because we have this in the way. Once again, the bitmap will be on the repartition streams over here. So whenever there's an operator between a scan and a repartition streams where there's a hash match with a bitmap, the bitmap will often get stuck at the repartition streams. And once again, we can see far fewer rows coming out of this than went in. All right? All together on that. Now, we could change this query plan up a good bit if we had a different index on posts. If we had, let's say, we had one index on posts on last editor user ID and one index on posts on owner user ID, then we would have probably two efficient nested loop join seeks into those. Well, another potential way to rewrite this query is to use union all and just generate a row number over the ID column and filter on where row number equals 1 on the way out. Now, if we do this, this is a much, much faster query pattern overall, and it doesn't require another index. This query finishes in about 313 seconds, and this is, I think, the query. This is the plan shape that I would want, because not only do we have the bitmap, but SQL Server does not choose an early aggregation, nor does it have to compute scalar down here. We have the bitmap that gets created, and if we peep down a little bit further, we can see that there is nothing between repartition streams and the index scan on posts. If we look at posts, the bitmap will have been applied to the index, so we were able to push this bitmap to the storage engine and start filtering out rows before they were even read from disk, which is a I think a much better plan. Now, SQL Server is still crying about wanting an index on owner user ID, which I get. And I don't know, if we're feeling really lucky, I don't know, let's just, well, you know what, why not? I'm feeling crazy. Let's just go create this index. I don't care anymore. It's Friday. What are you going to do? Fire me? So with that index in place, let's run this and let's see if we have any improvement. Well, I think so, but we got pretty far without having to add the index. Now the difference is we have a serial plan, there's no bitmaps, which kind of takes away from the whole point of my demo, which was to show you when bitmaps can't get pushed. So now we've got no parallel plan, we've got no hash joins, we've got no bitmaps. We do have a much faster query, which is cool, but even without that index, we got the query from about 2 seconds down to about 300 milliseconds just by changing the way it was written. Now, this is a pretty abstract way to write this query, right? Generating a row number over the ID that comes out of both of these union together and then filtering on that later. But, you know, these is the kind of tricks that you have to learn when you're going to be a professional query tuning person. And these are the kind of things that I show people in my presentations and my pre-cons, this kind of thing, these kind of tricks. So if you'd like to see more of that, why not join me sometime for one of these things? I put on a pretty good show. Even if you don't learn anything, I'll buy you a drink. Deal? If you learn nothing from me, I will buy you a drink. Not like together. Not like, you know, I'm not going to go drink with you. I'll give you money for a drink. Like, I'll give you a drink coupon. All right?